And it answers my question. All right, well, good evening or good afternoon, everyone, depending on where you're joining us from. My name is Sam Nasr, and this session will be on adding machine learning to .NET applications. A little bit about me. First, my Twitter handle is @SamNasr. I've been a software developer since 1995, and currently I'm the senior software engineer at NIS Technologies, where I do consulting as well as training. I've also been certified with a few certifications from Microsoft. And as Mayank said, I also run the Cleveland C# VB.NET user group. And in addition, I also run the .NET study group, which meets online, and we cover various .NET topics over the course of a given period. I've authored multiple articles for Visual Studio Magazine and been a 5-time Microsoft MVP, actually just received my 6th MVP award. A little shameless plug for the Cleveland C# VB.NET user group. So we meet every month. The meetings are free of charge and open to the public. And actually, as the schedule is aligned, we will be having a meeting tomorrow night at 6 p.m. Eastern. And we're going to have Scott Hanselman doing a variety of different demos in various versions of .NET, going from .NET 1 to .NET 8. So welcome you all to attend. Like I said, we cover a variety of topics related to .NET. And you can find the meeting information on meetup.com and search for the Cleveland C# VB.NET. And I can make that link available in chat later as well. So with the introductions aside, let's dive right into machine learning. So to give you an overview, basically what we're going to be doing is we're going to be creating a model within our .NET application, and we're going to be utilizing that model to make predictions. So the model essentially is going to be utilized by .NET or our .NET application, and we can do this in either .NET or .NET Core apps. The model that we develop could be available in either online or offline scenarios, and it depends on which type of scenario that you're going to be choosing, and we'll cover that once we start the demo. And essentially, what we're doing is we're creating patterns of data, or we're taking patterns of data, I should say, to be able to make predictions on them. So basically you feed it the data and it will come up with a formula of how it's going to predict a given value that you pass to it. So this is different than explicit logic where you have to guess what the formula would be, but rather you just simply feed the model builder the data, and then it will build the model for you. So with ML.NET, the model is an object that contains the transformations, and transformations is a fancy or mathematical way of saying the formula that's going to be produced on that data. So we give it a set of data, and then it creates a black box type of object. And then after we're done training it, then we can feed it in an input value and then get a output value as a prediction out of it. And so this data could vary. We could have data that is in simple linear regression, similar to what we see here. So the graph over on the left could be something that's attributed to housing prices, for example, such as the more square footage you have in a home, the higher the price will be. And certainly there are other factors that contribute to the home price, but let's just keep it simple and go with that generic rule. You could also have it where it's inversely proportional, meaning as the BMI rises, so does the good cholesterol drops, as we see over in the graph on the right. So it could be proportional or inversely proportional, as we see here. I see we have a comment in chat, and that is for the giveaway. So one of the things that I forgot to mention is, although it's a virtual meeting, I want to make it as interactive as possible. Feel free to jump in at any point in time with a question, either in chat or verbally. And if I overlook something in chat, I would ask Mayank to flag me and stop me.
Sure, both David and I would be monitoring the chat.
Excellent, appreciate that. So let's get into some of the terminology so that way we can talk the talk and eventually walk the walk. So for starters, when we look at a set of data, a feature is considered the input value. So let's take home pricing, for example. The input value would be the square footage, and then the output value would be the price of the home. So we look at input values and we call those features. And the predicted output value is the label, what we're getting out of it. As I mentioned earlier, a home price is attributed to multiple different features. So for example, we have square footage, we have the zip code that it's in, we have all the various amenities, whether it has a swimming pool, a hot tub, a fenced-in backyard, et cetera, et cetera. Those are all various features that contribute to the price of the home. So we have features of data going in, and then the label is what is coming out as the prediction. And then what's happening in between is what is known as the transform, or the type of prediction that will be taking place. So these are the three basic terms that we need to understand as we progress with building our demo. So we talked about building that prediction or that black box transform in the middle. What are the various types of predictions that we can build? There's a set there, classification and categorization, meaning that I give it a specific set of features and it will categorize it, whether it's good or bad. In our demo that we'll see later, we're going to feed it a variety of comments that we downloaded from Yelp, and it will tell us whether that comment is positive or if it's negative. There's regression, as we had seen earlier with the home prices. It can also detect an anomaly detection, meaning if we have a consistent amount of values, but then we have outliers, then it can be used to detect those outliers and the anomalies in there. Another type of prediction is the recommendation. I'm sure you've all heard of the website called Amazon.com, right? That's where half of my paycheck goes to every month. And so with every purchase you make, it tends to make a recommendation. Hey, well, how about this, right? So if I'm buying a cell phone off of Amazon, it's going to recommend that, well, you can have a handy case to go along with it, right? Or a screen protector, or a variety of other types, a USB cable charger, for example. So all these are recommendations that are made based on previous purchases. And likewise, I can train my model to be able to identify those purchases and all the other things that would go along with it. Last but not least, time series sequential data. And then with image classification, basically is if I give it an image and then it classifies it. So I could show it a picture and it would say, this is a vegetable or this is a fruit. And so it can categorize them, again, depending on how I train my model. Now, as far as the actual model development, it's essentially a cyclical process. And as you see in this graph, at the very beginning, we start by collecting and loading the data. That's probably the most important step. And this is one of the things that I advise clients about. You already have data sitting in your database, whether it's an archive database or your production database, but you have plenty of data. You can utilize that to train your model. So you take the data, and now you're going to be creating a pipeline in .NET, and we're going to do that using the append method, as you see noted in the box. And then we're going to train that model, and we do that using the fit method. After we're done training it, we want to evaluate it. How did the algorithm train the model? What is our prediction type going to look like? So we feed it some sample data, we evaluate the output, and then if we're happy, then we can continue on and save the model. If it's not satisfactory, the cycle repeats again, where we provide it more data, feed it into the pipeline, train it, and then evaluate it again. And on it goes until we reach a point of satisfaction that the evaluation is correct. So assuming we do reach that point and we're satisfied with it, the next thing to do is to be able to save that model, and then we can utilize it in our application. So as you see at the bottom, we have the save method for saving the model. That will save it off as a .zip file, and then we can incorporate it into our application. We do that by essentially using the load method. And what this will do is essentially take that zip file and it will load it within the .NET application. And then we can treat it just like any other object. We instantiate it, we call the methods to be able to pass in a prediction. And as you see there, we have the create prediction engine, and then we call the predict method. And so we pass it in a value based on the features that we have trained it on, and then we get an output value. So that's it in theory. Now, this is where the rubber meets the road. Oops, sorry for the backtrack. All right, so now I am ready to get my hands dirty and start developing code. The first thing that I need to do is make sure that I have the right libraries in place. So as a prerequisite, I would need to install the development environment for the .NET desktop applications. More importantly, as you see over on the right-hand side, I need to select the ML.NET model builder. Once that's selected, then I can go through and build it within Visual Studio using the GUI interface. So there are essentially 3 different methods that I can utilize to be able to build my model. I can do it through the UI, meaning once I have my project created, I can right-click on the project, select machine learning, and then be able to add in a machine learning project into my solution. A second way is I can do it programmatically using the Microsoft.ml NuGet package. And then a third, which is my least favorite, is the command line. I don't know why a lot of people love to work in the command line, but if that is your preference, you certainly have that option. So 3 different ways of being able to add in machine learning into your .NET applications. Any questions before we move on to the demo? I don't see any in chat, so there's one that popped up. Is Visual Studio 22 the first version of Visual Studio that supports the ML Builder? No, 2019 does. So you should be able to utilize it there. Any other questions or comments? All right, feel free to jump in at any point, and we'll proceed on with the demo. And so what I did was, for a demo, I have a console application, and I'm keeping things very simple, so that way we can focus more on the key aspects of it. So here, Visual Studio 2022, I did my prerequisite installation, and what I did in advance was just simply create an empty console app. So as you can tell, there's nothing in it. There's the standard hello world. There's also, looking at my Solution Explorer, you see that all I have is just my program.cs and the standard dependencies that got loaded. So now what I'm going to do is I'm going to right-click on the project, and then I'm going to select Add, and there you see Machine Learning Model. So I will select that. And now it's going to walk me through the user interface for adding a model. First, it's going to prompt me, what do I want to call it? I'll just accept the default, which is mlmodel1.mbconfig. I'll go ahead and add that in. We'll give it a minute to chug. And so far, all you see is that it just added in this mlmodel1.mbconfig file, which is essentially based on the settings that I'm going to walk through here through this GUI interface. So if you recall from the previous slide, we said that there are multiple types of predictions that we can use. So first and foremost, it's asking me, what scenario do you want to use? There's data classification, value prediction, image classification, etc. I'm going to go ahead and do data classification. Actually, let me backtrack for a second. So within each scenario, you see that there's a box underneath that specifies that it could be run locally, or if I can run it in Azure. Obviously, if I'm training it on large amounts of data, I don't want to tie up my server. I'd much rather do it in Azure, where I have better computing performance, and I'm offloading that entire payload to another server and not bogging down my own server. But others I can run locally, and so I can do it in either the online or offline. So here I can run it locally, and we'll go ahead and select data classification. Now it's prompting me for some additional, or it's giving me some additional details. First, it's telling me that it's going to be trained on my local machine, which I already know. And it's telling me Azure and GPU are currently not supported for this scenario. And just as a courtesy, it's giving me the local CPU environment that I'm using, as if I don't already know my local CPU. We'll proceed on to the next step. Now it's asking for the data. Is the data housed in a file, or is it in SQL Server that I can point to in a specific table. In this case, I have it in a tab delimited file. And so I will browse over to that file. And here I'm going to be utilizing some data that I downloaded from Yelp. And let's go ahead and open that data to see what it looks like. And we're using the world's best file editor, also known as Notepad. And what we see here is we have the comment in one column, and then in another column, keep in mind this is a tab delimited file. And in the other column, we have an indicator whether the comment is positive or if it's negative. And it just goes on for, how many do we have here? 1,000 records that we have in this file. So we'll close that, and then we'll select that file. And it's going to load the file and start processing the data. And by processing, I mean essentially previewing it. And it's going to give me a user-friendly display of the preview of the data. And then you see the other prompts will then be enabled after that. And like everything else running on hump day, it's running a little bit slow. So we'll give it just a second and it should load. While we're doing that, let's check chat for questions. All right.
I've got a question that maybe I can just shout out here.
Please.
So, you know, we hear a lot about and how great Python is for data science, and you know, there's a long history of those libraries being supported in Python. I guess I've always understood is ML.NET really is kind of the .NET equivalent to that. So where, you know, the things that traditionally you would have done in Python, now you can do in .NET, which if you've been a .NET programmer for a long time, like many of us have, it's probably more efficient than trying to go and learn Python, just, you know, because there's a barrier to another language. Is that a correct observation, or is my thinking flawed there? Can you maybe correct my mental model if it's wrong?
No, you're absolutely correct. And what's nice about it is I don't have to be a math wizard or have a degree in machine learning. All I'm doing is I'm going through the user interface and I'm selecting a few things, and it's doing all that behind the scenes. And as you'll see, as we start training it, it'll go through a variety of different algorithms. So again, it's mostly like a hands-off type of process for me. I'm just pointing it in the right direction, specifying a few things, and then it's going to take it and run. After I build the model, then I can use it in a .NET application. And in this case, we'll be using it in another project within the same solution. So the short answer to your question is yes.
Okay, great, thanks.
You're very welcome. Any other questions or comments?
Yeah, and I'll speak instead of typing. This is Dave. If you had chosen Azure for one of the applicable model types, would it be provisioning a VM, or would it be using the Azure ML service?
So for that one, I believe it's the Azure ML service. Then obviously you need the Azure subscription, and it would take you down that road of specifying all those details.
Okay.
Any other questions? All right. So where we left off was we were loading our data, which is approximately 1,000. Well, it's exactly 1,000 rows. And again, it contains two columns. We have the comment, and then we have the actual value. Now, if you notice, the next prompt here is it's actually asking me which column to predict, or the label. And if I don't know what that is, I just simply mouse over and it says, this is the target column that you want the model to predict. So do I want column 0 or column 1? Column 1 is what I want to predict. Column 0 is known as the feature, right? That's the input value. After specifying that, I simply go on to the next step. And now this is where I train it. So I provided the data. I specified the value that I want to be predicted. And so naturally, once I specify that value, all the other columns are going to be looked at as a feature or input values. In my example, I only had 2 columns, so naturally the first column became the feature. Now it's asking me for how much time do I want to spend training it. I'm going to select the default of 10 seconds and we'll click start training. But before I do, let me expand this output window and you'll see some things taking place. Actually, let me step that up to 15 seconds so it has a chance to go through more algorithms. And we'll click start training. Now, what it's doing here, it's going to start going through a variety of different algorithms to see what fits the data best. And it's going to go through them repeatedly during the time that I allocated. Now that it's done, it's giving me the best accuracy of 49%. And the models that it explored were 2. And these are the models that it's referring to, or the trainers. We'll wait until it finalizes that, and then it will enable the next step button.
If you would have given that more time, let's say 60 seconds, would you see your accuracy improve there? I guess, what would giving it more time do here?
That's exactly right. So giving it more time will allow it to go through more algorithms and more often. So if I was to let it run for a couple minutes, you'll see that it'll cycle through all the algorithms and then go through them again to better predict it. And you'll see the accuracy increase over time.
When you say other algorithms, do you mean more models like that would appear in that left-hand column?
No, the model is what I want to develop. The trainers, these are the algorithms that it's running through.
So the trainer column, you mean? There would be additional ones that would have...
Additional trainers. And actually, why don't we do that? Let's run it for 60. And we'll do train again.
I mean, yeah, I mean, as long as you're not charging, you know, our user group by the minute, I mean, let's go for it. 60 seconds, you know, I mean.
I didn't say I was. I didn't say I wasn't.
I don't know what contract you negotiated with us, but you know, it's,
You'll find out when you get the credit card bill.
all right, all right. Well, next time you're in Chicago, you look us up and we'll take you out for some pizza. So
Sounds good. Are you a Geno's or Giordano fan?
I would be a Lou Malnati's fan. So
All right, very good. So as you see over on the screen, it's going through currently for the 4th algorithm right now the 5th, and we got another 13 seconds remaining, and it just keeps chugging through them.
Does it help you in any way determine what the sort of optimal training time is? You know, so you can say, I'll wait an hour if that's going to be optimal versus, you know, 10 minutes or whatever.
So it's really hard to tell or it's hard to answer that question because it depends on your data. How many features do I have? How broad of the data do I have? How clean is my data, which is something we'll touch on later. So that's really hard to predict the optimum amount of time. That would happen with your specific scenario over time. So for example, let's say you're in the real estate industry and you know that you're feeding it, let's say 5 features for every home to be able to get 1 prediction out of it. Over time, you're going to know what's the optimal amount of time whenever you introduce a new table or a new set of data to it. So, you know, after some trial and error, you'll realize that for every 1,000 rows, I need to give it 1 full minute, for example, hypothetically, right?
Right.
And again, that varies over time. The advantage is the accuracy will continue to improve as you run through it more and more. So if you invest more time into it, you're not going to lose anything per se. It's just going to get more accurate.
Got it.
So as we see here, it ran through and we saw the accuracy had gone up for the 10 different algorithms that it had tried. And now when we look at our summary up here, we now have the best accuracy is 80%. And the training time that it spent was 55.37 seconds training it. The rest would be attributed to overhead where it launched the process versus stopping it. But now we have our accuracy stated. Let's assume that we're okay with this. The next step would be to evaluate it. And so by default, it loaded the first comment in, and it's asking me to click the predict button to see what the results would be. So when I say crust is not good, the model came back with the result of, we can have a drum roll, please, that it was a negative comment with 91% confidence. I can choose another value to throw in there. Since I don't like to type during demos, I love to do cut and paste. So I will paste, don't bother coming here. And the prediction for that, again, negative, it's a negative comment with 91% accuracy. If I was to say, I love the pizza here, and by the way, for whoever invited me to Chicago, I am a huge pizza fan, so I will definitely take you up on that. But I will say, I love the pizza here, click predict. And it comes back with the result of 1, which is positive, with an 89% confidence. So these last two statements were not included in the result set that, or in the data set that I fed it, but rather these were additional comments that I had put in. So after training it on 1,000 rows, it now knows good from bad, and it's able to predict. And the best way I can describe this is think of your 3-year-old son or daughter or niece or nephew. You're obviously training them on certain things that are good and certain things that are bad, right? The model is just like that. The more data you give it, the more it's going to realize what's good and what's bad on its own over time. No different than a 3-year-old, really, except it's all electronic and digitized. So let me pause here and see if there's any questions. And
Hello.
yes, go
Can you
ahead.
hear me? Oh, thank you. Just a question here to see if I understand correctly. When you are doing this sample data right here, is it running through all these trainers that we see here down below? I mean, like, are running different algorithms? I guess I didn't get correctly what the trainers here means.
So these are essentially libraries or algorithms that it's running through, and it's going through the data and trying to figure out the best pattern for a prediction. And so there's a variety here that you see, and typically that's how, unless you know what your data is going to be like, whether it's linear regression or classification, you have to try a variety of different algorithms on it in order to get the best results. Does that answer your question?
Yeah, so then like when you click there predict, does it run throughout like many of these algorithms and get kind of the most accurate one, something like that?
No, once I click the training, that's when it ran through. This was done on the previous step. If you recall here where I specified 60 seconds and I click train, that's when it came up with, that's when it ran through all those algorithms. The evaluate is where I'm feeding it some type of data to test it. And again, think of your 3-year-old son, for example, right? You tell him things like, don't take candy from strangers, don't use bad words. And eventually, if you train him on all the bad words, if you say, and you give him a bad word as an example, he'll say, oh, Dad, that's a bad word, right? It's the same thing here. I'm training it on a variety of different comments, showing it what's right and what's wrong, what's positive, what's negative. Once I've trained it on enough records, I can test it, throw a comment at it and say, is this positive or is it negative? And then it will produce the results as you see here on the screen. So the prediction doesn't run through the algorithms again. The prediction is basically testing the model that I'm building.
And in this case, it's essentially embedding that LBFGS trainer within the model and using just that algorithm when you hit predict. to give you your prediction.
Correct. So I've now created a prediction or a transformation, and I'm testing it to see if it's up to par with the comment that I gave it here, the sample comment. If it is, now I'm ready to go on to my next step, which is to incorporate it into my solution. But before we get to that, first of all, does that answer your question? I think that was Dave that asked that.
Yeah, and there was a chat question as well.
Okay, there is a chat question. Sam, it took a few seconds to make the prediction after you submitted it. Is that because of the power of your local machine? I'm curious if farming it out to Azure would give a faster response. So there is something happening on my machine, quite honestly. I'm not sure what, but I did get a message earlier that flashed that said something about the response time. I wasn't going to stop and fix it here. Typically, it doesn't take that long running on my machine. But to answer the second part of your question, can I farm it out to Azure to get a faster response? Yes, absolutely. But keep in mind, not all scenarios that I choose are available on Azure. If you recall, when I selected the scenario up here, I see which can run in Azure and which cannot. So object detection, for example, must run in Azure. I can't run that locally. Something like image classification, I have the option of either or. With data classification, my only option is to run it locally. Okay. Does that make sense, Rick?
Yeah, it does, Sam. That kind of makes me think, are there other options for the data classification where, and maybe it's probably outside the scope of this discussion, but could we farm it out to, say, a cluster, or a cluster of virtual machines or something like that?
Yeah, absolutely. And so if you were into machine learning DevOps, where it's basically DevOps for machine learning, where you're constantly training it and updating it with more data, there is some dedicated servers within that scheme that would allow you to train the model using those servers. They're dedicated for that. You wouldn't be doing it on your own dev machine. Okay.
Okay.
And like I said, there is something happening on my machine, but I'm not going to stop to reboot at this time. So we'll keep going.
And sorry, one more last question, just to follow up on that. I'm guessing that, and I really don't know much about this at all, but if instead of using the ML.NET Visual Studio plugin with this wizard, you could programmatically do what you're doing, I would imagine, and then execute that on VMs or whatever scale set or something within Azure to do exactly what you're doing, just programmatically. Is that accurate?
That is correct. And that will be the second demo that we'll go through.
Oh, sorry for stealing your thunder.
That's all good. It's all good. It's not stealing, it's a preview to my thunder. Let's look at it that way. All right. Any other comments or questions? And I like how people are jumping in verbally. This is good. Okay, so now that I'm satisfied with the results of my model, I've evaluated it. In my evaluation process here, things look good. Now the next step would be to incorporate it. And as you see, in a very user-friendly way, it's giving me a couple options. First, it's telling me your model is ready to use. I can use the snippet of code to be able to instantiate it and use it, or I can incorporate it as a separate project within my solution, either as another console application, as a web API, or I can use it in a notebook. So I'm going to use another console application. But before I go there, I just want to draw your attention to the fact that this is my original project. It still has the original program.cs where nothing's been modified. All I did was add in this ML model1.mb config. And there you see when I expand that, there you see a model1.zip. That is the entire transformation in a zip file. So I'm going to incorporate that as another console application in my solution, and we'll minimize this and click add to solution. We'll accept the default name of ML Model 1 console app 1, add to solution. And what it's going to do is essentially add it in as another project. And then I can utilize it. I can utilize the code of that model that I built originally in the ML Demo 1 project. And so you see the second one is expanded. Let me close this to avoid any confusion. Now, let's take a look at the program CS of the new project that was recently added. And we'll make this a startup project. So this is the default program.cs that was added in. And what it's doing here is we're instantiating a new model1.model input. So this is the model that I recently brought in from the previous projects. It's going to feed it some sample data. And this was the first comment in that table. And again, it's just giving me the boilerplate template that I can utilize. Then it's going to call the predict method, and then it's going to display the results. And so if we run through it, should pop up a console window any second. So there, in a very boilerplate type of way, it used the model that I developed, incorporated it into a new project, my console application, and it ran through it. And it took the input where it's specifying that column 0, which is a feature, is crust is not good. And then column 1, which is the label or the output, is going to be 0 or negative. And the predicted value was also negative. So this is the data straight out of the file that I sent it. And then this is the predicted value that it ran through. And of course, I have a read key statement at the end waiting for me to enter something in before the window would exit. Questions? No questions?
I'm curious. I'm really curious to see what the actual model looks like.
So it's a .zip. You really won't be able to see much. I mean, we can unzip it, but it's a lot of binary data.
Oh, okay, okay.
Yeah,
Not-
so
Not XML or JSON or something fun.
no, unfortunately not. But if you look at the ML Model 1 MB config, let's do. So this is the model that I developed and all the different selections that I went through in the user interface. And basically it's building a JSON file on the back end, similar to a config file. So we have the type of classification that I used. It's specified that I'm using tabular data, the path of the file of the data where it's at, the type of delimiter, column properties, algorithms that it ran through, et cetera, et cetera. So as I was going through all these clicking scenarios in that user interface, it was essentially building this config file on the back end. But this is not the model, just to clarify. This is just simply the template for creating the model, what I went through.
Got it. And probably it's not required as well. Like the only thing that is required would be the zip file.
I'm sorry, the only thing that's required there is what?
The only thing required to run the model, would it be only the zip file?
Correct. That's the only thing that I'm using here. Right.
Yeah, a follow-up question. On the program.cs, I didn't see any load for the zip file. Like, I'm trying to think about if how we could dynamically load the zip file from I don't know, I'm fetching it from a persistent storage or something, and then I want to load this model.
So there's other files that go along with it. So there's this ML model 1.consumption.cs. And so if you look in here, you see that we are loading the ML model 1.zip file. And then once we have that loaded, then we can utilize that in our program.cs.
Aha, got it. Thank you.
Okay. You're welcome. Any other questions? All right. So let's put this one aside and we'll bring in another demo. So this one I'm running in Visual Studio 2019, just for the simple fact that I've done this before and wanted to demonstrate to someone else that had asked if we can run this in previous versions of Visual Studio. So this is done in VS 2019, and it's done differently in the sense that everything here is done programmatically. So if we look at Solution Explorer, we'll see that, again, it's another console application. And instead of using the GUI interface, I'm going to be incorporating the Microsoft.ml NuGet packages, and then I'm going to be doing everything programmatically. So this specific demo is about housing prices, as if I didn't talk about housing prices enough, right? So this is an actual demo of that. And again, keeping it very simple in the sense that we're making a linear regression of just square footage and the price of the home. So to do that, we have a couple objects that we're defining and keeping everything in one file. I know it's not best practice, but it's nice to see everything as we're demoing it. So first we have the housing data, and that's going to be described as the size and the price. So the size will be considered a feature, and then the price will be the label. That is the output that I'm getting. And we'll touch on those in just a little bit. And then we have our prediction that's going to be the output, which is the price, and that's a separate class altogether. And then we get into our main method. So first, we're going to instantiate the ML context object. And if you recall from the one of the slides we've done previously, what we have to do is collect the data, then we have to create the pipeline, and then train it using the fit method, and then evaluate it. If we're happy, then we can save it at that point after the evaluation is successful. If not, we would have to cycle through it again until we get a successful evaluation. So having said all that, we have some data that is hard-coded here. And then the next thing I'm going to do is I'm going to import the training data. So I'm going to load from enumerable the house data, which I defined up above. In step number 2, I'm going to specify and prepare the model training pipeline. So using the ML context that I instantiated up above, I'm going to create a pipeline by adding in size, which I'm calling a feature. And I'm going to also specify price, which is going to be my label. The maximum number of times I want to run through this data is 100 times. The next step would be to train my model, and I do that using the fit method, and I pass in the training data, which is the pipeline that I set up above on line 31. In step number 4, we now make a prediction where I'm passing in a value. I'm using a size of 2,500 square feet. And if you notice, that size does not exist in the data that I'm training it on. I'm training it on values below and values above, but not that specific value. Because I want to see, is it going to predict it? Is it going to be in the ballpark? And so I set this as my prediction, and then I instantiate the create prediction engine class, and then pass in the predict method, and I'm going to pass in the size. And then the next step is just simply to output what that value is. And so we'll go through and we'll train it, and we'll step through it one step at a time. And the breakpoint hit. So we have the ML context. We're going to instantiate it. Now we have the training data. Now we're going to set the pipeline. And we're specifying what's our feature and what's our label. We're going to train it maximum number of 100 times. So this is going to take just a second. And now we're ready for the prediction. We'll step through that prediction. We'll get the price and then display it out to the user in the console application. And there's our console window. So the predicted price for a 2,500 square foot home is 275,000. And if I compare that with the data that I fed it, so an 1,100 square foot home is 120,000, a 1,900 square foot home is 230,000, so on and so forth. If we look at the 2,800 square feet, that's going to be, whoops. There's my console window. So a 2,800 square feet is going to be 300,000. So given those values, I see that a home that's 2,500 square feet is 275,000, which looking at this, yeah, makes sense, right? Wouldn't you all agree? We seem to be right on point with that. And so I can go ahead and press enter to move on to the next line. Excuse this. This is simply just redundant data that I put in. I meant to delete it, but the point is, if I'm satisfied with it, now I can actually fast forward and get down here, where now I can save my model, and I'm specifying that I'm going to be saving it as a .zip. So this is the model object that I created using the pipeline of training the data. And then it will save that as a .zip. And we'll go ahead and execute that step, and done. And so we completed our code. Now, if we look over on the folder where that solution is located, so we'll see that is in bin, in debug, and you see that I have a model.zip created at 8:53 p.m. And since I'm on Eastern time zone, it matches with the current clock. Okay, so this example allowed me to do everything programmatically, no user interface, everything done in source code and maintained in the source code. And then when I was satisfied with the results, I was able to make a call to the save method and be able to save that as a .zip file. Any questions? Comments?
Hey, this is Mike. Just a quick question about this model itself. So while we use that, does that also improve? Or do we have to retrain that?
So if you want to improve it, yeah, you would have to train it. So there's the difference between supervised learning versus unsupervised learning. And that's a different realm, but essentially with this type of model, you would have to train it and update it, and then redeploy it out again into your application. Think of it like a class library that you would be using. Let's say you have a class library for calculating employee bonuses, for example. And if that formula changes, you have to recompile that library and then redeploy it out to production, right? It's the same thing with the machine learning model. If I get more data and I want to retrain it, I would do that and then redeploy the model again.
Gotcha. Thank you.
You're very welcome.
So,
do we just
I'm sorry, go ahead, continue.
so if we retrain the model, do we just update the model .zip in the application?
Yes. So after you train it and you're satisfied with the results of retraining it, then you're going to save it off again. And it's going to be a model.zip, and you redeploy that and overwrite the existing one.
Okay.
So I was going to ask, if you, let's just say, for instance, you trained a model with, I don't know, 1,000 lines of text, And then, you generate the zip file, you have your model created now, you start using it to get predictions. And then you get another 100 lines of text you want to add to the training. Do you start all over again and do 1100 lines, or can you sort of save the original state and then just sort of append to that to get an updated model so it takes less time to retrain it?
So if you recall in my previous demo, let me pull that up. So this solution consists of two projects. The first one was used to simply create the model, and the second one is using the model, right? So going through your scenario, I train it here on 1,000 lines, and then I deploy it. Now I get another 100 lines, and I need to train it on that additional 100 lines. I would simply run it through those 100 lines into the model that I have here in this project. And then once it's done, then I can redeploy it. And now I have a model that contains all 1,100.
Okay, so you're running the additional 100 against the pre-existing model that was already generated. So
Correct.
Yeah, gotcha.
If I wanted to run just on those 100 alone and ignore everything else or delete it, I would delete the model and start over again.
Got it. Thanks.
You're welcome. I don't
Does
see
the
anything in
zip file
chat.
increase in size?
I'm sorry?
If we increase the does the zip file increase in size if we increase the training data, or?
So that's one of those questions where the answer is it depends. It depends on the features. It depends on the labels. It depends on the number of rows. But we're not talking a significant impact. I mean, to give you an idea, if we look at the model.zip, so it's 270K zipped. Obviously, if you have a more complex algorithm, it's going to be a little bit bigger, but I don't expect it to get into the gigabytes. Okay. We have a comment in chat.
Yeah, it was more of a comment than a question. I just was kind of searching for the documentation on this and saw about loading data from other types of data sources.
Yeah, and Microsoft, again, has done a great job with documenting and tutorials. So I invite you all to explore that as well. And I have a link to that later. Any other questions or comments? All right. So let's get back into our PowerPoint. So the time to train, this is basically a general rule of thumb regarding the size of the data, but it is not a hard and fast rule that you have to abide by. You can, like I said earlier, you can invest more time into it and it won't be time lost. The data will only get better with additional training time. So if you want to improve performance and the accuracy for the model, what are some of the things that you could do? First and foremost, give it more data. But the key thing is it's not just more data, it has to be clean, meaningful data. So looking at our housing prices, for example, I can't just go off of the square footage. Obviously, some of the factors are the zip code and the location where it's at, the amenities, air conditioning, swimming pool, fenced backyard, etc. And the more features I have, the more it's going to be more accurate, correct? Another thing to keep in mind, I also need to have it where the data is within context. So I can't just throw square footage, zip code, and amenities in it. I also have to look at other things. I could have a mansion that has a termite problem that could be selling for pennies on the dollar, right? Or mold conditions or fire damage. So I need to take all that into consideration as well. Because if I have a data set to what I showed you earlier with the square footage, I could have a mansion that is, let's say, 12,000 square feet, but the price is only $20,000, right? That's going to really skew my data if I don't provide the feature saying that there was termite damage or fire damage included on that property. So more data, clean, meaningful data, meaning I remove all the outliers and any repetitive, or I'm sorry, remove all the outliers or anything that is not clean, and then provide the context to better describe the records that I'm feeding it. So that way it makes sense in the end when I have the predicted value. Another thing that I can utilize is something called cross-validation. And what that is basically it's a model evaluation technique where it splits the data into several partitions and then trains multiple algorithms on each of those partitions. So this can be effective for training models with smaller data sets, where I divide and conquer essentially. And of course, as we had seen, running through different algorithms will help me to be able to improve the performance and the accuracy overall. Some of the machine learning scenarios, just to touch on, similar to what we talked about earlier, with the classification, I can identify customer feedback as we did in our demo of either good or bad. I can use it for the home pricing to predict on a linear scale or regression what that pricing would be. I can also use it for anomaly detection, making recommendations, or time series or sequential data such as the forecasting of product sales, and image classification, where I can produce an object and then it will classify it in one of the categories that I trained it on. Some of the gotchas to watch out for. 32-bit is supported on Windows, except for using TensorFlow or LightGBM and ONNX-related functionality. So those are all different libraries that can be used with machinelearning.net. If you're working in your code and you end up getting a Microsoft ML currently supports x64, x86 processor, the issue or the way to resolve that is just simply go to project settings and change your target to 64-bit. And then a problem that I had in previous versions is that it would say the new project created by the UI, which if you recall, we created our model in one project, and then I selected to edit on the solution as another project. A problem I had in the past that has not surfaced recently due to Visual Studio updates is that it would say the new project created by the UI would have a different version of .NET. So I would be developing on .NET 6, but the new project that I added in was showing up as .NET 5. And it would give me a compile time error saying that there's a mismatch. And again, all I would do is just go into the settings, change that to a different target, and everything was copacetic. So I'm only mentioning that only if you're working with older versions or if you haven't updated Visual Studio, you may encounter that error. And let me pause one last minute and ask if there's any questions. Because if there are no questions for me, I got some questions for you. What is it that we learned here today? I would love to hear your feedback, either verbally or in chat. What are some of the things that kind of stuck with you and sounded interesting as we were going through the demos? And I'll help lead the conversation. What are the 3 different ways that I can create or add in machine learning into my .NET application?
Yeah, I think one of the things I learned is I had never really played with this before, and it was just really easy to go into Visual Studio. They made it really easy, to get started. You kind of select a text file, and it really just kind of, guides you through, which, I think is really interesting and really useful, and especially for somebody who's very much a beginner, hasn't done a whole lot of stuff with this.
Right. Absolutely. And the one thing every organization has, data, right? The data is already there, and you already have Visual Studio. It's just a matter of marrying the two. Incorporating the .NET machine learning is very simple, as you mentioned, and you can just take in that data and start processing it. So what are the 3 different ways for adding machine learning to our applications? So obviously the GUI, as David mentioned, going through the interface. The second method is programmatically using the NuGet packages. And then third is the command line interface, where I can just start typing away and be able to add in or create a model and then incorporate that into my solution.
Is the command line via some executable? Is it PowerShell kind of thing? Or
I'm sorry?
what's the CLI for that again? Is it just some executable file with arguments and all that to do those different stages of the creation?
So the command line interface is basically the window that pops up at the bottom of Visual Studio where you can enter in commands and be able to create a project through that, similar to Git commands in a similar fashion.
But there's a specific ML.NET CLI that you'd be using to do that then?
So you would need the ML NuGet package to be incorporated into that. And you can do all that through the command line.
Okay.
So some references I wanted to touch on. Again, hats off to Microsoft for some great documentation. There's the ML.NET guide, also the glossary of terms. This can be found at deepai.org. And then some additional tips on improving the machine learning performance. If you're thinking of utilizing machine learning in your organization and you're not sure how, feel free to reach out. I would be happy to help you or anyone else at NIS. You can reach out to us. The website is nistechnologies.com. In addition, there are courses available in machine learning as well as development courses. And if you need to reach me, probably the best way is to go to Linktree, and I'll make all my information available in just a second. But if you're interested in GitHub or my YouTube channel or LinkedIn, all that is available on my Linktree. Well, more specifically, if there's any questions I can help you with or get you on your way to using ML.NET in your solution, you can reach out to me via email, snasr@nistechnologies.com, Twitter @SamNasr, and then my blog, I put in some various articles, tips and tricks, tech events. I post that on my blog, and that's samnasr.blogspot.com. And if we haven't connected on LinkedIn, I invite you to do so. And with that, there's also one more link that I would like to share with you, and that is for the Cleveland C# VB.NET user group. And let me post that while we're waiting for that to load in the browser. The CLI makes me think that it would be possible to add on a pipeline, for instance, so whenever the training data changes a model, could append new data. Besides that, I guess I learned more on how to use and expose ML services. Thanks, Sam. You're very welcome. It's my pleasure to help, Kelvin. And pulling up the meetup.com site. And as I mentioned, Scott Hanselman will be joining us tomorrow night. And he's going to be going through a variety of different demos related to .NET. And let me post that link into chat. So there's the meetup site, and I'll post the link in chat. I would love for you all to join us tomorrow night. So there's the link in chat, and there's my contact information. And if there's no questions or comments, I thank you all for having me. It's been a lot of fun. Really appreciated the interaction online, and hope I can be of help to you in the future.